All right, here we're going to do this again, the IDSA. This is all about the IDSA Zero Trust Identity. We're really focusing on integrations of technology to support a Zero Trust identity story. These are all GA integrations around the identity-centric security components, which I couldn't think of in the first session. Go ahead, hit the slide. I don't know who has it.
Who has the clicker?
Oh, who took the clicker? It's hiding.
Yeah, that's it. All right, and then once again, futures now. We're talking about zero trust. This is real stuff. This is stuff that's doing it today to support an entire zero trust story, or a zero trust identity story, where basically user data, user devices, all of these components are not trusted and must be verified as you go through the system. Next. Again, this is the complete security for AWS deployment, which includes Okta, Netskope, LogRhythm, and I'm forgetting CyberArk. Thank you, Edward. Go ahead, next slide. So you'll see the speakers up here. Up here is the use cases. I'm going to turn this over to Stephen Lee from Okta at this point.
Great. Thank you, Jerry. I guarantee you this is going to be the best choreographed presentation today we've got. 4 products that are involved in this, and each product has a person coming up to do the demonstration. We wanted to find a use case that would resonate with folks, and I certainly work with a lot of customers who have this problem of basically deploying stuff in AWS. And as an identity management product, people ask us some questions around AWS, usually about access, about provisioning accounts, about things like MFA. But that's never it, right? When you look at sort of the broader deployment, and I look at our DevOps team when they're dealing with AWS, it's not just about that. It's about worrying about things like privileged account access. It's not just about logging into the AWS console. It's about the stuff that you bring up. It's about the S3 and the EC2 instances that you're managing. It's also about those very Linux systems and Windows servers that you're running. It's also about all the operations that someone might do when they go into AWS, and it's also about gathering all that info and make some sense out of it and potentially avoid any sort of suspicious activities from actually happening. So when you look at this particular combo of products, right, Okta, CyberArk, Netskope, and LogRhythm, and we're really covering kind of the access management portion of this identity puzzle. And from on the right-hand side, obviously Okta as an access management product, and we have LogRhythm that's acting as I guess both SIEM and also to some extent UEBA, if you think about it. And then CASB, obviously Netskope is going to do that part, and then privileged account management is going to be done by CyberArk. At a very high level, these are the things that we're responsible for, and you'll see sort of glimpses of these bullet points showing up during the demo. So I'll just let you kind of read it, and then obviously the folks will go a little deeper into exactly how each product is satisfying the various use cases that we're going to go through. But just to kind of give you a high-level idea of what we're trying to demo versus just jumping into the demo, this is really the high-level topology that we've built out, right? So the kind of orange, yellowish box is really that full AWS environment, and really the stuff on the right-hand side is what you're trying to protect, right? It's both access to the AWS console, it is the OSs and the databases that you've booted up in your AWS environment, and what you're actually doing in that environment. Now, the reason why we've put CyberArk and LogRhythm also in that yellow thing is in this particular topology, to be fully transparent, they're also running in that AWS environment with CyberArk and the LogRhythm code sitting in there. Okta and Netskope were both running in sort of our cloud native environment. So there's an Okta tenant that we've booted out, and then same thing with Netskope. And just as a high level, if you look at these 4 products, and remember the previous slide with the columns of the feature set, with Okta, you're really focusing around single sign-on and multi-factor authentication. So the end-user access, logging with the username, password, using it as a single sign-on product, but also enforcing MFA. So we are doing SAML sort of into AWS, but then technically, if you really want to dive into it, there is a SAML relationship between us and Netskope, which is acting as that CASB product proxying the traffic that's happening between the end user agent, your browser, and what's actually happening in AWS. CyberArk, obviously, as a privileged account management product, is managing the OSs and the databases that are running inside AWS. So if you want to access the Linux system or running SQL query against a database or access to a Windows server, CyberArk is going to play that PAM role. There's a SAML integration between Okta and CyberArk, so that allows us to do single sign-on as well as enforcing MFA. And then Netskope, as I said earlier, playing the role of a CASB product, acting as the proxy, and really able to see what the end user is doing. So when you think about authentication, post-authentication, Okta is kind of done, right? We don't know what the user is doing within the AWS environment, but that's still part of the AWS security story that you'd like to paint, right? You'd like to be able to cover that. So Netskope is allowing us to really capture that part of user access and allowing us to do additional authorization in terms of what a user can and cannot do. And then finally, LogRhythm, not only acting as a SIEM product, right, being able to gather the information from everybody, but the ability to carry out incident response, to be able to react to certain activities, and that's what we're going to show, right? The ability for it to look at the data that's coming in from the various systems and detect that, oh, if something is not, maybe it's not right, it has the ability to go out to another target where it can potentially impact user experience. And you've got very disruptive type of impact. You can go ahead and disable an account, but you can also do some fine-grained stuff, right? Maybe you step up the authentication that's required for a certain user or certain groups of users needing access to the system based on the activity that you're seeing. So with that, I'm going to hand it over to Matt Egan, and I guess each person coming up should probably introduce themselves very quickly. I actually forgot to introduce myself, so I'm Senior Director, Business Development and Partner Solutions at Okta, and this is Matt.
All right, perfect. So he's queued that up. I'm going to jump into it in the interest of time. So the first use case, problem statement demo that you're going to see is addressing the fact that passwords are inherently insecure. I don't need to hammer on that. And the point here is, consider the impact of breached credentials. If somebody was, if it was just credentials that were used to protect your AWS environment, the impact associated with that. So, actually, back to the slides for just a minute, and we'll build this out. We're going to go just a touch deeper. So as we go through there, again, building out on what Stephen just talked through. So the flow that we're going to watch, just because it goes by very fast, we're looking at a sign-in attempt. So we're going to step through what happens. User logs into Okta, then MFA is enforced when they invoke or attempt to sign into Netskope through Okta. Pointing out here too that with our integration with Netskope, the SP ACS URL that would have traditionally taken somebody to AWS has been replaced with an ACS URL that instead takes them to Netskope. So Netskope's in this flow, and so we enforce MFA based on the application and the conditions that are met there. And Stephen was right; this doesn't fit as well on this screen as it did on my screen. And then again, when somebody signs into CyberArk, we see that MFA prompt is going to come in to play as well. So just touching on that. So what does it look like now? I'm going to skip the sign in. We're already signed into my Okta instance. And to get into AWS, if you're watching really close, you'll see some URL action, but it's MFA enforced by Okta. Get the push notification here. To approve and accept. And then our auth is going to carry on. And now I'm going to be signed in. If you're looking at this URL, you'll see that I'm not going to AWS directly. I'm going to Netskope, which is then proxying the connection, taking me or brokering that connection to get me into AWS. And a few things to talk about in there. In that SAML assertion, Okta is asserting the IAM role that somebody possesses or is allowed to or is entitled to within AWS, and the name ID. And it looks like the demo demons are going to get us early in this demo. We don't get to see that, but trust me, it's an AWS console. with me signed in as myself, and I have access to AWS resources. Hopefully this doesn't carry on. That's we'll do one more just for fun. And if this doesn't fly, we'll just wave hands a little bit more. There we go. There we go. It's loading. Okay. All right. Ta-da! That was the demo. I'm signed in with an IAM role, a federated admin. That was asserted through from Okta based on group memberships. MFA policy was applied based on group membership and the target application in the network zone that I was in. And if we can go back to the slides, we'll move through this quickly. So policies that are enforced in Okta to apply MFA and select the available factors that are used. Simple configuration in there. The points to drive home on this one. What does the IDP? What role does the IDP? And this could be any IDP that you're using. But what are the recipes to make this work in this environment? You need an IDP that can do things with extensible policies, so that we're not constantly doing MFA. We need to be able to do adaptive or conditional access. Extensible MFA offerings, right? Using the right factor at the right time. SMS, I attended a great session. They were talking about, how SMS is not a very strong factor. It isn't, but it's appropriate in some use cases. I would say for AWS, it's not appropriate, and you should be using different factors. And then, your IDP should have robust third-party integrations, and I think, as members of the IDSA, a lot of these IDPs are stepping up in that game. So that is it for that. I'm going to turn it over to Edward. He's going to step on to use case 2. And for people with questions, we're going to do group questions at the end in the back.
Yes. Can I switch?
Yeah, so you want to talk slides and I'll do
Josh, switch here. Excellent. I'm Edward Nunez. I'm actually with CyberArk. I've been with CyberArk for about 9 years. I work for the business development group, and I work as the technical lead with integrations with technology vendors. So the idea of use case number 2 is actually the policy of least privilege. The idea is that you don't want to have many people with a lot of power. You can have a few accounts that are actually the ones that have high privilege permissions, and then you have people going through CyberArk to actually request access to the systems they need and the accounts they need. The idea here is that we are going to show the flow in terms of how do you go from Okta, go to CyberArk, try to get connected to a system because you need to apply a patch, for example, and then you need to get approved first before you actually get to that, and then you have complete power, but you are still audited and recorded. Oops, I think I went back. Which slide I'm showing here? Okay, excellent. So the idea here, and I can go back. Again, you go to Okta, Okta authenticates you via MFA and so on. Then it goes into logging into CyberArk via federated through Okta. And then once you get to CyberArk, you want to get to the actual resource you want to connect to. So let's say that you need to connect to a system, a Unix server, in order to apply a patch. So you do that, you get actually request an approval. During that process, somebody else needs to approve, most probably the team leader, the manager, etc. And then eventually you get access to the system. So I'm going to switch to the demo. And here you go. Okay, so in this case, I'm authenticating to Okta. So pretty straightforward here. Actually, let me type it. So I get requested for MFA. I send a push. In this case, it's gonna go to my phone. I can actually respond from my phone or from my watch. So I approve that out. That goes and actually gets me in within Okta dashboard. Let's wait for a moment. So I'm back to the Okta dashboard. In this case, I'm gonna do MFA into basically federation into CyberArk. So I get access to this. And again, I think the demo GATs are not in place. I get into CyberArk, and I basically have the system that I want to connect to and apply the patch. So in this case, I'm gonna just try to connect. During the process of connection, then I basically need to establish a reason why I'm doing it. Maybe I need to request a time frame for access. And in this case, I'm gonna do just a simple one saying that I need to apply a patch. Once you do this, actually, you're still not able to connect. Somebody else needs to approve it. I have another window here with an approver connection. So when I do a refresh here, you'll see that he has, as an incoming request, the approval. This goes also to his email and so on, so he can actually respond from his email or from his phone as well. So let's say that he says, yes, it's okay, go ahead. And in this case, he gives the permission to the user that is requesting, and I'm back to CyberArk as that user. I basically have access now, and I can connect. So when I can click connect here, what happened is CyberArk is gonna establish a connection to that system. You already have access to it. You were approved, and basically I'm connecting without actually knowing the credential for that system. I get connected. Everything I do during this session is gonna be recorded. So if I start typing things, or I do this, let's say that that's what I had to do. So I finish that session, I go back to what I was doing, I finish my work. From the perspective of auditing and recording, we can actually see that the person with permission to actually audit will see that Edward got connected and he executed specific statements. And you can actually see the video if you needed to for exit evidence. So that's basically, and back to the slides, please. That was basically the demo for use case 2. This is just in case the demo GATS didn't work, but that was the flow that we just saw. And follow up, we can actually have dual control enforcement, so nobody has to have really superpowers and only get access when they need it. We can actually isolate the session and record all the audit tasks all the tasks that have been done in that system. And because of the integrations we have with Okta, with other vendors, we can actually do authentication via other vendors. We can actually send all the activity that is being done at that time to other vendors for follow-up in terms of incident response and so on. And that's where Netskope comes to work. Thanks a lot. Oops.
All righty. We've got 1 minute and 17 seconds, so we're going to be very quick. No. All right. Got a little buffer there. Perfect. Yeah, so in our use case 3, what we're going to be walking through is we're going to take a look at AWS and how we can actually control what's happening there. And we're going to do that taking a look at other types of information. So in this particular use case, what we'll end up doing is we're going to have a user that gets authenticated through Okta. So we'll multi-factor them, so I have an additional layer of security. And then what's going to happen is they're going to get reverse proxied through Netskope. So we're going to redirect them where Netskope will do TLS, SSL decryption, and inspect for sensitive content, looking for malware as well, and ransomware, and just applying controls. These controls are going to be based upon policies using role-based access controls. So in this particular instance, what we're going to be doing is tying into some directory services. And based upon what group these users are a part of, are going to determine what they can and can't do. So a few things I want to point out here. When we take a look at this integration, and I'm sure it's top of mind for everybody, some of the key things that we're thinking about lately is, how do I get all of this data that I have, whether it's threat intelligence, whether it's logs coming from additional platforms, how do I get that information, make sense of it, and utilize that very quickly to increase our security posture? And it's one of these buttons here. There we go. So when we start taking a look here, you'll see in number one, again, like I said, we're going to log in through Okta. We're going to get passed through Netskope, where we're going to apply policies based upon role access control. Logs are going to be sent over to LogRhythm. So in this particular instance, what's going to happen is we have a user that is authorized to access AWS. However, they are not authorized to stop instances. So we're going to have Emily log in. She's going to go and attempt to stop an instance. She should get blocked. And then those logs are going to be sent over to LogRhythm. At that point in time, LogRhythm's are going to run some algorithms that it has and do a smart response. So that smart response is going to actually communicate over with CyberArk, where CyberArk's going to go and disable that user. So we're going to block the activity. We're going to see them doing something that we consider to be highly sensitive and proactively prevent them from having access to this particular system. So if you had think of a rogue admin, it's probably the best example there. All right.
All right, so guys, I'm Emily Henriksen, sales engineer with LogRhythm. I'll go through the demonstration piece. I mean, on Okta, I'm a privileged user. I have access to CyberArk. I can do whatever I need to do. But say I wasn't a very happy employee. Say I was disgruntled. I'm trying to, looking to get out, and I'm going to cause some damage before I go. Looking at the running instances, you know what? There's this sensitive server here. I bet it would really make me mad if I. There we go. If I stopped this from running, so you know what? Let's come in here and stop. Wait, let's stop from running, and it's not. Okay. Well, as a disgruntled user, maybe that would be enough for me to go about and try to figure out some other way to really get the man before I leave. But in the event that, go back to the slides here real quick. In the event that that doesn't, you need some sort of monitoring that will alarm to these users when there we go. When they do start going rogue.
Yeah, and so you'll notice there that we actually block the access. And so what I'm showcasing here is if we take a look, here's a policy, and that's the policy that we're using right there. And that policy is very specific to this instance of AWS. So keep in mind, we're being very granular looking at that specific instance. And if we go through and we take a look at the alert details, there's two sections up there. And these, whoops, put that back. In those alert details, there's a lot of granular information in there. So for example, looking at who the user is, source address, what type of browser they were using, refer URLs, all different types of things that you can use if you do have an investigation, and additional stuff that you could use for threat hunting. And so now what we have is Emily's showing us the alert that's coming up within LogRhythm.
So, and you're exactly right. I mean, from this, we can just take a look at the alarm itself in the inspector tab over here. It tells me exactly what's going on. There's Emily Henriksen, who's doing some nefarious things. Looks like there's multiple stop. They were in fact blocked. If we look up here at the summary, we can see that there's a block associated with it. So nothing was actually done, but you know what, this is unusual for that user. I'm going to want to respond so that in the event this is a rogue user, I'm going to be able to launch an investigation right from the SIEM. See all of the data throughout the entire AWS environment, what they're doing, why they're acting anomalous. But in the meantime, let's disable this user so that they can't cause any damage in the event that that is their intention. So the smart response to the disable user, you can actually have that automatically trigger, or you can set that approval process as I did. And by doing so, me as a user, pretending I'm that nefarious user again, I no longer have access. You can see Emily Henriksen is disabled. I no longer have access to the tools that I would have otherwise been able to use to my advantage. So if we could go back to the slides one last time. So there's a couple of slides I guess we'll skip right over. There we go.
All right. And so when we take a look here, what is it? Here's the follow-up piece. What are the takeaways? So central enforcement point for cloud services, doing that on sanctioned services with unmanaged assets. So what we just showed you just now was a reverse proxy. So that's pretty cool. So what we ended up doing is it doesn't matter what device you're on, you're going to be pushed through Netskope so that we can provide access controls there. Talked about the rich contextual data that can be sent into various tool sets. In this example, LogRhythm, where we're going to actually make some smart decisions and increase our security posture very quickly. Then the adaptive security. You saw that we were able to go and take that account based upon a behavior, and we're able to disable that account, thus mitigating that risk. And next is questions.
Yeah, so just as a 30-second wrap-up, since we're already a little late, maybe we'll have to take the questions in the back. But you know, when you look at a zero trust story, right, it really is about, I mean, literally not trusting anyone. Whenever I can prompt for challenges, whenever I can squeeze in approval and workflows, and whenever I can do detective and preventative type of policies, you give yourself an opportunity to do it. And here's just an example. Right? We only have 4 products up there. Imagine you're deploying this in an environment where maybe you have also F5 and some other product running out in AWS to protect your data. You have a bunch of SaaS apps. You're talking about a developer having access to Jira's and a whole bunch of stuff. You start expanding this story, and you can basically apply these various devices in different parts of the way. It gives you a very powerful set of tools to really manage your AWS environment. So. With that, I'd like to thank everybody that was on stage. I wasn't kidding about the choreography being slightly complicated, but thank you, and we'd be happy to answer any questions outside.
Thank you.